What's our first even, guys?
28.
28. Okay. 28. Final answer for the left Riemann sum. 9.67. Nope. 688. Technically. Right endpoint. 11.688. The area was somewhere in between there, because one's a lower and one's an upper. Did you guys have to write all these nasty fractions? Ooh, ears open real fast, because if you're depending on looking at this later and copying it down, I will think you're cheating because you do not have to write it this way. How should you guys have written it? Someone give me something that you did a little different.
F of something.
Yeah, F of what? Maybe I should do F ofs? First of all, was the 1/4 cool?
Yes.
Yeah, because what was the distance between 1 and 3? What distance is between 1 and 3? 2. 2 units, right? Cut into how many rectangles? 8. So therefore they're going to be 1/4 wide each, right? Where did 2 come from for the left endpoint or left end approximation? What was 2? F of 1, right? You can do F of 1. How can you do F of 1 in your calculator again? Yeah, you plug in the function to your y1, right? And then after you plug in your function to your y1 for whatever, then you can do, can't you do y1 of 1, cool kids? Oh, we talked about this on Friday. Please don't say that you just didn't do anything this weekend. How do you do F of 1 in your calculator if you have a function in the y1? Alpha trace, you do y bars, right? You do y bars in order to solve. I'm pulling it up, I'm coming back. You can do y1 of 1. Who would be your next y1 if you're going between 1 and 3? And you're supposed to cut all of this into 8s. Well, stink, there's 2, but that's cut into halves. Well, there's 3 halves and 5 halves, but stink, that's cut into 4ths, right? What are the other x values you needed? Yeah, you also needed to do 5/4, right? That'd be 5/4, 7/4. So what's 7? What would this one be? 9/4. What would this one be?
11/4.
Look at you guys, pattern followers. Good. So what am I going to keep on doing past 1? What would be the next 2? F of 5/4. The next 2 would be F of 3 halves, and then F of 7/4, then F of 2, then F of, I'm going to do a dot, dot, dot. How high do we go for the left endpoint? Him? Take away 1. So how high do we go? 11. What's going to change when we try to plug in for our right endpoint? Instead of starting at 1, oh, you don't use the height at 1. Who do you use the height at? 5/4. Good. So you start at 5/4 and you go all the way to 3, right? And why am I once again reminding you of your graphing calculator and how awesome of a tool he can be sometimes? Because number 1, hold on, don't look at this. This is BC. Come on. Sequence mode. That's fun. We did that in pre-cal. Anyway, do that. Can't you easily just do 1 divided by 4 times and then do your y1 of, are we tracking, guys? Plus, then can't we do y1 of 1/4, then plus, or 5/4, then y1 of 3 halves, plus y1 of 7/4. What did I do? Alpha what? Alpha trace. Or you can do alpha y equals and then go over and hit the y bar button. Do you see it? Man, that saves you time. But it only saves you time if you do what in the y equals? You gotta plug in the function. So who is the function for this guy? Louder. X squared plus 1?
Yeah.
So you would have to plug in your function first for number, whatever this is. For number 28. You'd have to plug in, oh, struggle. Don't even know what I just did. Just pretend I didn't do it. You would have to plug in your function first, then you can go ahead to your graphing calculator. And guys, once again, I did, oh my goodness gracious, man. anybody see above the smart board? Am I anywhere near the minimize
Right
button?
there. Way down there. Close.
There?
Right there.
No, that's nice. To the left? Right there. Yeah. Right there.
So somehow I like made it big.
Pointer. There you go.
Okay. How many of you guys used the graphing calculator this weekend and you used it well? That's it. The rest of you guys, do you have questions? Because can't you tell how much time this was? We did this on Friday. You were supposed to be focused. Questions? You know how to find all the buttons? Okay. And it is what it is. Final answers, you guys already saw them. Let's keep going. I know, but the clear ink is on the top where I can't see it. Hold on. People who can see above the smart board. Am I somewhere near the clear inky thing?
Yes.
Where's the handlebar-y thing? Is there a handlebar-y thing?
See.
Kyle, can you go to this screen and then is there a handlebar where you can drag him over here somewhere?
Wait, the
Where I can
handlebar?
actually get him. This guy?
Oh, this thing right here?
Yeah, is there a way that you can drag him?
Yeah.
Nothing.
Right.
Oh, not that guy, sorry.
Not that
Wrong
one?
guy.
This
The guy at
one?
the very top,
This
yeah.
one?
Can you drag him anyway? Ooh, wait, you went somewhere. Where
Yeah,
is he?
I'm driving to the
Oh,
bottom.
look at the bottom.
Yeah, I'm
Perfect.
going to
Leave
the
him
bottom.
right there. Thanks, bud.
I highlighted the tops.
No, you're good. Clear ink. Thank you, Kyle. Woo! What's the next even? 36. Okay, someone have be on deck for the next even. 36. Was this the upper sum, lower sum one? Upper sum 0.859, lower sum 0.659. Which I think corresponded to left and right. Is that right? Or maybe right and left. So 0.859 and 0.659. Number next one. 60 what? Whew, I made it. 68. They wrote it funny. They wrote it funny, but don't stress about the funny. Can you guys at least see where they found their midpoints? These ones. So I think you're going between 1 and 2, right? You had to cut it into fourths? No. That's not right. It's not between 1 and 2. It's between 0 and 2, right? You guys are just like nodding and agreeing. Not helpful. Okay. Is that better? 0 and 2?
Yeah.
Okay. So where's the 0 and the 1/2 and the 1 and the 3/2 being plugged in? Why are they plugging in weird things like 1/4?
Medium.
It's the
Midpoint.
midpoint. What's the midpoint between 0 and 1/2? Exactly. What's the midpoint between 1/2 and 1? 3/4. And hence they keep on going to get to 3/4, the 5/4, the 7/4. Where do all these nasty numbers come from?
You plug them to
Yeah. 1/2 is how big the bases are of each of my little rectangles in here. But instead of using f of 0, instead of using f of 1/2, we use f of the midpoint 1/4, etc., etc., etc. Right?
Yeah.
Okay. So final answer, you guys can see it. The clear ink is down here. I can find it. Thank you, Kyle. Final answer 8.171. Any more evens? 70? Are you sure? Yeah, we totally didn't do that in period 1. Not helpful. Wasting time. Anything else? Okay. Any questions on odds, real quick? All right, we're out of here. Let's get back into our notes section 4.3. If you guys have any questions, please come in and ask. Otherwise, I cannot be chasing you, literally or figuratively. I need you to come to me. Otherwise, we're not going very far. Okay. If you guys didn't get your forever card on Friday, make sure you get it now. Did we get to any examples past this? No, we didn't. But we were ahead of period 1, so we're doing pretty good. And they had technology problems, so we're doing actually really, really good. technically, homework 28 should be due tomorrow, but the sad news is, period 1 is a little bit behind, so technically they're supposed to be starting it tonight. Due on Wednesday, you guys technically should have it due tomorrow because you'll be fine, but you might wait to go over events until Wednesday, but please don't wait until Wednesday or Tuesday night to start it. Or I should say Wednesday morning. Don't do either of those. Alright, everybody still copying this forever card? Forever number 34 has approximate integrals. I also want you guys to go ahead and put down the other way of saying them. Riemann sums. Riemann was the mathematician who wrote the calculus book that first outlined this procedure, I think is how it worked, if I remember right. We can do Riemann sums, or we can approximate with rectangles. We can also approximate with trapezoids. We can approximate with rectangles or trapezoids. Heights are always function values, bases are always delta x's. If we're allowed to make them equal, then we use this little formula down below. If we're not allowed to make them equal, then we just have to use whatever change in x's they give us. Sad but true. Alright, but no one raised their hand, they're still writing, so let's keep going. What's going on with approximating? As you fit in more and more and more rectangles, 3, that's alright. 8 is a lot better. 8,000, oh my goodness, that's getting stinking close. Maybe negligibly close. Negligible. I think we use that word when we took limits. Oh, wait a minute, why am I talking about limits?
Because it's infinitely closer.
Because we're going to infinity, and the only way we can go to infinity is with limits. You can't probably see it, I can kind of see it, but right there, there's a shadow that says, oh wait, we can do that with limits.
Oh,
Yeah.
I see that.
If I was in
I
Smart
see it.
Notebook, I would click on it, and it would get really nice and big, but I'm not in Smart Notebook, so it will just say, hey, it's there. Limit.
Oh, okay.
We can go to infinity, right? And beyond. Okay.
What's beyond?
Infinity and life.
Infinity plus 1, which is still really just infinity. Infinity squared is stronger.
And there's also infinity cube.
Oh my goodness. Go first. Definite integral! This is technically the definition of a definite integral. The nice thing is, though, we don't have to be able to solve using this. We just have to be able to recognize it. Remember, this is a BC sort of thing. You have to solve this. We don't have to solve using that. We just have to be able to recognize it. However, sorry, there's an N on top. We are going to learn how to solve using this. Next section. Right now we know how to approximate that using rectangles or trapezoids, but we don't know how to actually solve it with antiderivatives. Don't worry, they're coming back. I knew you were worried. They're coming back. It's not quite yet.
When are we done with them?
Integrals?
Yeah.
Right after the AP. So May.
Oh. So I went back to derivative.
Yeah.
You will.
Yeah.
Because that's how you check
You're
it.
going into computer science. I'm not gonna stop.
In words. Why did I put it? Because it's important. You need to know what that definite integral stands for. The area between a function f of x and the x-axis between a to b is the definite integral from. Now, I'm not going to probably ask this wording of you on a forever quiz. Wait, forever quiz? Why am I talking about that?
Coming up soon.
We've had a lot of them. We better have one sooner, or else we'll be in trouble.
We just had one.
Now let's just have one this.
we had one like the day we came back.
Yeah, it was like, that was forever
It
ago.
doesn't count forever. Yes, it does.
This is 35, right? Not 34.
Yeah.
Are my numbers right? Are your numbers right?
Sure. Where's the loudest?
This one is 35. Oh. So, when you see this, you're going to tell me, who is this? The definite integral of, no, who is he? The definite integral of, see, this is why I have the wording underlined. You don't know how to tell me what that guy is.
Oh,
There you go, now we got it. So now do we know how to say it? The definite integral of f of x from a to b. You can technically interchange that. From a to b of f of x, I will technically take either. You guys almost there? For Joyce, hold on, I'm getting something for him. What's today? The 20.
Kurt. That's what I like.
Anyway,
Zero progression.
Joyce is going. Would it be faster if I just like dragged it in there? It wouldn't, right? Alright. Okay. Let's keep going. So, how do we look at these things below? These Riemann sums below. How can we change the form of the Riemann sums to be integrals using the definition that you guys just wrote down? If, hold on. I give you just a couple more details. How would you write them as definite integrals using the definition that you just made it forever out of up above? What'd you guys do for A? What do you think? Now, some of you might be a little stuck on this guy, being like, ah, ha, 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 it's not the same. Okay, let me describe to you what that little guy is. This little guy, the little double lines with the delta. You guys remember back when we did vectors?
Oh, man.
You're welcome. Honors was doing that today. In physics, this little guy stands for a partition. Oh, sorry. Well, it does stand for that. We used to talk about the magnitude of a vector. That was a long time ago. The magnitude or the how muchness of a vector. In this context, the partition is the length of the subinterval. Magnitude was length, partition is length. Anyway, this is the length of the subinterval. And the nice thing is this won't show up on the AP, or it shouldn't, at least not needing to know the name, etc. It's partition. It's the partition. But long story short, as the subinterval goes to 0, wait a minute, guys, what happens when we have, say, three rectangles, and then a second later we're like, oh, never mind, let's go ahead and get a better approximation. Let's fit in instead 6 rectangles. Then the second later we're like, no, let's get even better. Let's fit in 12 rectangles. Question, what's going on to the poor little bases of these little rectangles? Oh, so what's the partition approaching? 0. So as you fit in more and more and more and more and more and more, infinitely many rectangles, What's happening to the partition? It's approaching 0. So don't stress about that extra stuff. It's just another way of writing it. Oh my goodness, I have to go back through all of this. Don't worry about the partition. He doesn't change things. He doesn't mess anything up. Basically, you can still use the same definition and say, oh, it's another way of saying it. But as the partition goes to 0, I get infinitely many rectangles, and I can say, what integral is this? The definite integral from 2 of who's that? Oh wait. Who is this? Yeah, it's just x. So instead of saying 6c sub I, I'm going to say 6x times 4 minus x quantity squared. And then delta x is the same thing as dx. To make my notation proper, I'm going to go ahead and change that parenthesis to b instead. Bracket. That's all the question was asking for. Not to solve it, not to estimate using rectangles or trapezoids, just to rewrite it. Just to rewrite it. Okay, letter B. Ooh. Go, Chris.
There's like 2 little lines around the delta. What does that mean?
Partition, it just means as the base goes to 0. So as they get thinner and thinner and thinner. But I still get to use the same integral definition up above. Letter B. How can we write this integral? The integral from 2 of okay. Times dun, dun, dun. So do you see how to go from one form to the other, just to how to go back and forth? Does it make sense? The bounds had to be given to you so that you know the from and the to, the lower and the higher. The function I had to change c sub I to be x, etc., etc., etc. But otherwise, we're okay to go.
From example A and B.
Yeah.
Does it really matter, like, if you include dx in the bracket?
Oh, thank you. I was just quickly writing and not paying attention. It does matter.
Okay.
Not immensely, but it does matter. Yeah, that's better. Technically, 4 should be done. Okay. This dx needs to be the bookend, so yeah, he needs to be outside. Alright, we are surpassing period 1. Yay! Actually, no, they started writing this, never mind. Oh, yeah. Which is what we're supposed to do. What they were supposed to do. But it wasn't their fault. It wasn't anyone's fault per se, it was just technology failed. That's it. The computer knows. Go team.
We solved it.
Oh my goodness, it's a yellow box! Dun, 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 dun.
Not a
No.
problem. It's just a trick.
Dun, dun.
It's a trick. It was just a clever ruse.
The section did 3.
Wait, is that
A to A.
A to A?
Yep.
Alright.
What? How does that make sense? I
Oh,
don't
equals zero.
understand.
Just
A
let
to
it happen.
A.
It equals 0 though, so that makes sense.
Yeah, because if you start somewhere and you don't go anywhere, then you don't have any area, right?
Yeah.
That's the Calc AB joke from last year. How many hours of sleep are you going to get? The integral from A to A of f of x dx. You Let's see. As long as it's memorable. The integral from A to A doesn't go anywhere, so it's 0 every time. The integral from B to A, what? The bigger number's on the bottom? It's backwards of what I think. Exactly, it's backwards of what I think. Yeah. Make it negative the normal way. Number 3 says, no big deal, you can take a constant out. Oh, we kind of know that from antiderivatives, right guys? Number 4 says, to get from A to B, you could technically go to C first. To get from A to B, you could technically go to C first. Whether or not he's an in-between number or an outside number. So for number 4, this is the illustration I'm doing real quick. Kiddos, to get from here to in and out, could you just go down Lassen?
Yeah.
If anybody doesn't know this because you don't drive yet, you just go down that road right there.
Yes.
Okay, could you go up to Lassen and then over? Yes. Or could you go to Starbucks first and then go to In-N-Out?
Yes.
Either the one down on Nordoff or the one up on, oh my goodness, Devonshire. By the new Panera, by the way. Anyway, coming back. Coming back. Now, question: is Starbucks in between here and In-N-Out?
No.
No, but couldn't you go there and then go to the other?
Yeah.
Same thing with integrals. Even if the number is not in between, we can still go there first and then backtrack. Or sidetrack, or diagonal track, whatever. Number 5 says sum or difference. Hey, doesn't that happen with antiderivatives too? Oh. Couple more seconds. Properties of definite integrals. Things that we can say or do, ways that we can change them or simplify them. And then we're going to use them in examples. Ready? Okay, use your group if you didn't get it all. So, what if you're given these 2 facts? The definite integral from 1 to 4 of f of x dx is equal to 2, and the integral from 1 to 4 of g of x dx is equal to negative 10. P.S. The AP guys love to give you facts without giving you the functions. Struggle. They try to confuse you with their clues. They try to confuse you with their clues all the time. How could we legally rewrite letter A?
Integral 1 to 4. Or to the 3 now, say you can. F of x dx. Minus integral to 1 to 4 g of x dx.
Now pause. You guys tracking?
Yes.
What properties have we used? Yeah. We used the pull the k out one, right? This guy? And didn't we also use the you can split up the sum or difference guy?
Yeah.
So, do we legally rearrange or rewrite that integral problem? Yeah. So what can we do? Plug it in, plug it in. What? Plug in him for 2. And plug in him for, we end up with 6 plus 10 is dun, 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 dun. Does that make sense? Now let's see if things get a little bit different on the second part, letter B. The integral from 4 to 1 of 2f of x. Pause, think it through. Give me your best hypothesis for an answer. -4. How on earth did you guys figure out the right answer? Tell me legally.
You can rewrite it as negative integral 1 to 4. Or 1 to
can rewrite it from going 1 to 4, but if you switch the bounds, you have to make it opposite. So we switch the bounds and say, oh, we're going backwards. Hey, put it in negative. F of x dx. Who does this guy become?
2, 2.
And what's 2 times negative 2? Got it. Dun, 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 dun. Dun, dun. How about the next one? Uh-oh, this just got tricky. So you already have the other 2 clues, right? Now given another clue that the integral from 1 to 2 of f of x dx is negative 5.
You go from 1 to 2 and 1 to 4.
Kyle's saying something like, hey, you can go from 1 to 2 and then from 2 to 4. Is that true? That's like you can go to Starbucks in between here and In-N-Out. Who does that equal? The integral from
1 to 4.
So the integral from 1 to 4 could equal the integral from 1 to 2. And then the integral from 2 to 4. Except this one, you're not exactly hitting Starbucks on the way. You're hitting, let's say you're going from here to McDonald's and you decide to stop at In-N-Out. Right? It's like in betweenish.
Wait, but aren't you finding
Ah, well hold on, we haven't finished
2?
quite yet, but does the equation make sense?
Not exactly.
Go back to those properties
Oh
on the
wait,
page
no,
before.
because it's telling you to find 2 to 4, not 1.
Yeah, but to get from, ready? To get from 1 to 4, you could go from 1 to 2 and then 2 to 4, right?
Oh, never mind. I see what you're doing.
So I'm just kind of setting up the formula, but now we need to go ahead and still solve. Like, for instance, what of these pieces do we know?
The first and second.
Yeah, we know from 1 to 4 is what from the clue up above?
2.
2. We know from 1 to 2 is what? And who don't we know? Right? Now in math, we don't usually put a question mark. I mean, I do, but maybe you should. We could do something like X. Nope, we're already using him. There you go. Let's make it A. Nope, that's a bound. How about B? Nope, that doesn't work. How about C? Nope, that's a constant. How about D? Sure. We'll use D. So then what does D equal?
7.
And who is D? Yep. D4. Done.
And then
Got it. Do you guys see how we can use those properties to solve problems without even having to do areas or anything else?
Yeah.
So we have to know how to work with these integrals because sometimes they'll give us stuff to do and they won't even give us functions to draw a graph, let alone approximate with a graph, et cetera, et cetera, et cetera. Anybody still writing down these answers? Okay, a couple more seconds. Oh, go ahead, Carla.
I'm confused about how you got from 1 to 2.
Oh, because I saw my clue that they gave. Right here, this one. And I already had the clues from up above. These ones. Yeah, so then I tried to just think of, okay, well, if I have 1 to 4 and if I have 1 to 2, how can I set this up to make them equal each other? Is that better?
How do you get C?
I knew C because I saw the number that they used to split up. So this one up here went from 1 to 4, and I saw them randomly using 2, so I'm like, that must have been the in-between number. Does that make sense, kind of? Good, thanks. Any other questions on this one before I move on? Let me give directions real quick, because it might not be what you think. Show the enclosed area using a definite interval. Wait, enclosed area. Do you guys see enclosed areas? Yeah. Well, not under the line. If it's enclosed, that means it's stuck, right? Because otherwise, if it's infinite, if it kept going, that's infinite. Well, we don't want infinite. We want enclosed. And so enclosed is going to be stuck between the function and the x-axis between 0 and 2. Oh my goodness, wait, area under a function above the x-axis between 0 to 2. What am I just talking about? Yeah, from 2 to of the function. Yeah, so for your dx. That's all I'm asking for. The area enclosed, write it as a definite interval. Check. Now, kiddos, could we actually solve this guy using geometry? Yeah, we could do 1/2 base times height, right? No big deal. And that'd be pretty spiffy and all. And the base we could say is 2 pretty quick, and the height we could say is 4 pretty quick, but that's not technically what they were asking. What would you do on letter B? How would you write that enclosed area? So you see the enclosed area, right? Roughly. Forgive my color outside the lines because my highlighter is too thick. Let me try this one. Oh, that's better. Okay, what do I do? 0 to 4. Of? Hold on. Wait, but we have y's. But wait, what did you put in my little bounds? You put x's, didn't you?
So it'll be 0
If I have y's and y's and y's and y's, who do I need here?
0 to 2.
Y's. Oh. Kiddos, you technically have more than enough to finish up homework on 4-3. However, I will give you the same grace extended to period 1. But we are moving on tomorrow, 0 to 2. Good job, cool kids. Talk to you later. If you need me, I'll be out.